Hello and welcome to the Integrations webinar of OutSystems, where we'll be talking about web services and extension modules. Our agenda for today is about how to consume and expose REST and SOAP web services, and how to test and debug an extension, how to integrate external databases through the use of extensions as well. We're going to start, obviously, by how to consume and expose web services. This presentation is mostly demo-based. I have a small introduction about web services that may be interesting, but for most time, we'll be watching some demos on how to do these things, because they are very important for you to understand how to do these things. Now, what are web services? Web services are language-agnostic procedures that are called over the internet. Language agnostic being that it doesn't matter how they were developed, whether they were developed under a Windows system, Mac, Unix, whether they were developed using C++, C#, Java, PHP, or whatever. Either of these languages, all these technologies can talk to one another using these two standards that we've talked about. These are SOAP and REST mostly. SOAP and REST. Now, what are the differences between them? Well, SOAP is a formal standard. It has a formalization of a contract. That is, there's a file called a WSDL file, or WSDL if you prefer, contracts that describes what the service is providing to third parties, exposing to third parties, to consumers. So because this file is computer generated and can be read by a computer, programming languages can provide you with some support on whether or not you're actually exposing what you promised to expose. And when you consume a service, whether the service is actually providing you what it promised, and if you're reading it correctly, and how to convert the data that the service has sent over to you. SOAP uses XML to carry requests and responses, and it's chosen in situations where bug trapping is critical because of these advantages, usually in business-to-business communication. REST services, on the other hand, are a de facto standard. There's no formal standard defining a RESTful service. There are contenders to these formats, to these contract files, but none has been set and adopted generally. It uses JSON to carry requests and responses, which is a much more compact form rather than XML. So they're usually chosen for services where it's very important to have a fast response time and low battery consumption. In OutSystems, as we'll see in the demo, to consume a web service, a SOAP web service, is very simple. You start by going to the Logic tab, select Consume the Web Service. You type in the WSDL URL, and from there, the platform knows everything there is to know about the service and exposes actions that you can use in your own actions. The reverse, to expose a SOAP service, is also extremely simple. You select the other option from the same menu, which is to expose a web service. You then create methods in the service, and these methods are nothing more than actions that you can program and develop just like any other actions in the platform, and they will run whenever a consumer is calling your SOAP service. SOAP services are exposed using these URLs. So you will be able to access a SOAP service using the host name that you have defined for your environment, followed by the module name, and then the web service name. Pay attention, it's the service name, not the method name that you defined inside the service, followed by .asmx. And the WSDL file is the same thing. You simply add $WSDL. The OutSystems Platform exposes this WSDL as a WSDL file with both SOAP 1.1 and 1.2 bindings. For REST services, the process is very similar. Use consume REST API menu option, and then add a single method. We won't be talking about add all methods. This is mostly used when you have one of the contenders for RESTful services contracts, which is Swagger specification. The services exposed by OutSystems, the RESTful services exposed by OutSystems, include a Swagger specification. So if you're consuming a service as it was exposed by OutSystems, then you can use this option, add all methods, and this will work pretty much the same as in SOAP. It will detect which are the available methods, the data types, and so on. But for the most services out there, this will not be a possibility. These services, RESTful services, do not have a formal contract, so the platform does the best it can by trying to guess what is returned by the service from a sample of a trial run that you provide to the platform. So you select add single method, you provide the URL for the service, go over to the test tab, fill in any data that needs to be filled in to effectively make a test to the service. You press the button, and the platform shows you the response. If this looks like a typical response from the service, a complete response that can be used as an example, then you push this button, copy to response body, which will copy this data to this tab here, the body tab. And this will be used by the platform to generate the proper structures for input in the REST service. You then press OK, and everything is created for you. Exposing a service, again, is the reverse process, very similar to a SOAP process, has nothing new. So we're going to start with the interesting parts, which are the demos. I have here for you an international grocery store that wants to show product prices in 3 different currencies: euro, dollar, and pound. As you'll see in the demo, currently the screen that we're trying to generate for this simply shows the prices as the same value among all these currencies because we don't have the exchange rates between them. Now, we could simply ask somebody from the company, hey, you got to go daily and go over to our bank's website, figure out the exchange rates, and fill in this information here on the back office so that the website has an up-to-date information. But this won't work when that person is on holiday, when that person is sick, on sick leave, and so on. So why don't we get an up-to-date exchange rate from a web service? This is what we're going to do in the demo. Now, the demo is developed in 2 different modules that are part of the same application. The prices core module exposes an action, a public action, which is called get products with prices externally, and the prices module is the user interface that consumes the prices core module and uses this action to get a list of products that will include the prices for euro, dollar, and pound. The prices core module is responsible for generating the exchange rates and the up-to-date prices in dollar and pound because the database it has only has an item, an attribute, that specifies the unit price in euro. Unit prices in dollar and pound are shown, will be calculated by the core. Let's see the demo doing this. The service we'll be using, as explained in the demo, is the European Central Bank exchange rate RESTful service.
So here we have open the prices core module and the get exchange rate action. Now this action is used by the public get products with prices action, which returns to the prices module the list of products with all the prices for all currencies. Now this action, get products with prices, will call the get exchange rate action to get the exchange rate for the dollar, and then the same for the British pound, and it's this action's responsibility to provide the exchange rate. Now currently we're simply returning a fixed exchange rate of 1.0 for all currencies, which means that when we run the prices application, we get the same price on every currency, as we can see here. Now, in order to change this, in order for the core module, the get exchange rate action, to actually use the current exchange rate for a currency, we're going to use the European Central Bank's RESTful service that provides this information live. Now, this RESTful service is actually a statistical database where you can fetch lots of information. So I have here on my cheat sheet the actual URL that I need to use to get the exchange rate, current exchange rate for a single currency against a euro. Now, as you can see here, this is where I'm going to place the three-letter currency name, ISO currency name, that I want to fetch the exchange rate for. So I'm just going to copy this, and I'm going to add a new RESTful service consumption. So I'm going to consume a RESTful API. I'm going to add a single method and paste my URL over here. And like I said, I'm going to remove this fixed dollar amount for a dynamic currency name of 3 letters parameter, like it says here in the help. Now, next thing I'm going to do is going to go over to headers and auth authentication. This web service, RESTful web service, actually is very, very advanced and provides many different ways of communication. And this means that I need to tell it what I expect to be returned. That's done with the HTTP accept header, for which, I'm going to change over to the test, for which accept header I'm going to provide application JSON, because I need to get back a JSON response. In terms of tests, I'm going to use for currency name the USD amount. Now I'm going to test this. Let's see if it works. And here we go. We seem to have a response. And this is the exchange rate over here. But the service returns a whole lot of other things that I'm currently not interested in, but it's still something that the service provides. Now note, when I hit OK, Service Studio is going to create the actual structure that are required to read this data. That means that it will create structures for all these things over here. That's normal, we don't need them, but they will be created. For each of these items, it will create structures that have similar or the same name. For instance, for the action value, JSON value, it's going to create an action structure name, structure attribute name, valid from, series, and here we're going to have a problem, because this is not valid as a structure attribute name. So Service Studio is simply going to create a standardized name, something like attribute 1 over here. Then we have observations, and then it's going to have attribute 1 again, or attribute 2, because again, this is not valid as an attribute name in Service Studio. But it will know how to map things from the service into our structure. So let's just remember, the data that we need is in datasets, series, something, observations, something. And this is where we're going to find the value that we need. Note that this is an array of values. It's always an array with a single value for our kind of call, but it's returned as an array. So this is going to be a list in Service Studio terminology, a list of decimals. Okay, so I have this example. It seems reasonable, so I'm going to copy this to response body so that Service Studio uses this as an example to create the structures. I'm going to hit OK. And there we go. We have here the service. I'm just going to rename it to something a bit prettier, ECB. And we have here the name of the method that's being called. It's called getDatum. I'm going to call it getExchangeRate. And it gets two arguments, a currency name, the accept header, and returns the response, which is, as we can see now in the ECB structure, a structure that has all those information that is required to provide data returned from the web service. Now, in the accept header, the accept is always application JSON, so I'm going to add something here, a default value. I'm going to take it as not mandatory so that I can type this. It's going to be application JSON. Let's see if I don't make any mistakes. And this indicates whether the input parameter is sent when it's missing. So I'm going to hit yes. Yes, please. Send this on. So if I don't provide a value for accept, this is going to be used, which is what I want. It's default. So it's easier to use this function this way. Okay, so I've got the service now. What else do I need? I need to use it. And I need to use it in this action here, which is already open. So I'm going to make room for the call. Just drag the call over here. This is going to call Service Studio. I need to provide a currency name. Now this already has an input parameter that I'm going to use here. There we go. And the accept header, I'm going to leave it open and void, so it just uses the default value. And here, instead of providing a static 1.0 as a return value, I'm going to fetch what was returned by the service response. So service response, it's in datasets, which is an array, then it's series, then remember those zeros, it's attribute 1, then observations, then attribute 1 again, it's an array, and it's an array of decimals, and this is what we want. So I'm going to delete this, and just double click here, and it's fine, it's perfect, because that is a decimal. Done, and it should be done. Let's try this. I'm going to hit publish here. Let's wait a bit while this publishes. And what's happening now is every time we try to call this to get the entire list with prices, at the head of this call, two calls are made to get exchange rate to our web service, one for the dollar and one for the British pound, to retrieve their amounts. And then those values are used for each row that is fetched from the internal database in this module. Now this has been published, but I need to refresh. References here in the consumer. So I'm just going to open and say OK, because the data that was exposed is still the same. And publish this one as well. And then we're going to test this to see if it works. Now let's wait a second. It's publishing. Now we can open this and let's see if this works. And here we go. Now we have different values for euro, dollar, and pound sterling. And this is actually live exchange rates retrieved from the European Central Bank. Let's see if this is correct. Now I'm going just to copy this and to ask Google how much are these euros in USD. And Google says 1.36, which is correct. And how about in British pounds? 1.05, which is correct as well. So this is perfect. is providing the correct exchange rates, and we are seeing live exchange rates for this service.
Now, we've consumed the web service. It was actually even a rather complex web service, RESTful web service. And now life goes on, and our CTO decides to split those two modules into different servers. And that will mean that they need to communicate not over exposed actions like it was done previously, but rather over services. So the team that handles the prices core module decides that, well, we don't know what other teams would prefer, so we will just expose both SOAP and REST services to provide the same list of products. So we'll have a get products with prices version with SOAP and a get products with prices version with REST. Both will be exposed by the core module. And then the team leading the user interface decides, well, out of these, this is a business-to-business communication. I'm going to use and consume the SOAP version. So let's see how do we expose SOAP and REST services, and then how do we consume SOAP services. And to do this, we have another demo.
Okay. Now we're going to pretend that prices core and prices are on different servers. And prices core wants to expose its services not only to prices, but to other modules that may want to use it. It wants to expose them in whichever way those modules prefer to consume them, this being either SOAP or REST. So we're going to expose services. We're going to prices core, REST, and let's start exposing a RESTful API. We get this the chance to rename this. We're going to call it core REST API. And now we're just going to add a new API method. We're going to call this the get products with prices REST, which has pretty much the same input arguments as this one and the output arguments. The output arguments being a products list, which is actually a structure products with prices list. So this is what we're going to do here. We're going to add an output argument, products list, which is actually a list of the structure called products with prices. Here we go. And we have the method defined, and we double click on it, and it's simply an action like any other action in Service Studio that we can program. And this we're going to do by simply calling our internal function, get products with prices. There's no input arguments, and then simply copying the result over to the output argument. So we're going to assign our output argument with whatever our internal function also returns. And that is it. We're going to do the same thing for SOAP. We're going to expose a web service. Again, we can rename it. We're going to call it core SOAP API. We're going to add a method. Again, get products with prices SOAP. The same thing. Add an output parameter, products list, which is of type list of products with prices. Here we go. Now it is defined. We're going to just assign here HTTP security. It's always a good idea. And double click on it. We have the empty action here. Same idea. We call our internal function. Then we assign the output argument that we have defined here with the return value from our function. And there we go. Now, the services are now exposed to the world, and we can use them elsewhere. Now, while this is publishing, how are we going to call the SOAP API? Now, even though there's information for that here, for the RESTful APIs, we don't have information directly here, but the manuals tell us what is proper URL, and we've seen this before. So I have here on my cheat sheet the actual URL for this demo. Copy this, go back here, and go over to prices. And in prices, before I had the actual products with prices using in the preparation a call to the external function that was exposed by the prices core module. And now I don't want to do this. I want to consume a SOAP service. So I'm going over to the logic, SOAP, consume a SOAP web service. Now the platform has already pasted for me the service. I'm going to hit OK. And the platform already knows what's being provided because Weasel, or WSDL if you prefer, description of the SOAP service as provided by the core module gives me the entire description of what's available. So I don't need to go over and test something and then have the platform create structure for me. This is all done automatically. So I simply need to replace this. I'm going to delete this one with a call to the service. And that's it. And now, of course, I have errors because on my interface, I was using the prior data from the other action, and I need to use the new action, which calls the web service. So source record list, it's no longer this one here, but this one here. Here we go. And these expressions need to be slightly changed as well. So product table, prices name. Here we go over to product with prices unit, and so on. And that's it. Now, we've changed our interface, our screen. The preparation now uses a web service to fetch the information, and the screen is using that web service's return data rather than the exposed action from the other module to display the information it gets. Now let's see if this is working. It's now deploying. And we're going to launch this. And here we go. 123, 136, 105, just like before. And we're getting the same values, still getting the data that's being returned by products core, but over a web service.
And these were web services, best practices, how to create them, how to consume, how to expose, how to work with web services in general. RESTful web services still have options for configurability. You can trap the call before it's being made to the exposing service, and actually trap also the response before the platform processes the result into its internal structures. This way you can handle lots of variability in the way REST services who do not follow a standard because they're not actually defined formally as a standard in the way they work. Now, moving on with the integrations, let's create extensions. We're going to start with the first demo. And the use case is that the CMO, Chief Marketing Officer, decides that prices should look prettier. There should be multiples of 5 cents. You should not have something that ends in 3, 23, 27, 41, and so on. So we're going to add this functionality, and we're going to create a function that rounds prices to 5 cents in C# and in Java. Let's look at the demo.
Now we are going to create a new extension with special functionality to round the currency amounts that we see here to a minimum amount. In this case, 5 cents for each of these currencies. Now that functionality could be coded as an action. It's a simple formula, but we're going to use an extension as an example. So we're going over to Integration Studio. And in Integration Studio, we're going to create a new extension called MC Prices Lib. And this is the name of the extension. Now, this is going to have an action, which we're going to call, let me see my cheat sheet here, round price. And this will be a function that we can call it from within the expressions in Service Studio. Now, obviously, this means that it needs to have at least one output or a single output, and I'm going to let it create the output. I want that output to be the result price, so it's going to be named price out. And it's going to be a currency, obviously. And it's going to have two input arguments, price in, which is also a currency, and minimum currency, which is the minimum amount we want to round up to. So these are the arguments, one output argument and two input arguments. This is my action. And now this extension is going to be coded, let's go back, both in .NET and in Java, so that we can see how it works in both. So we're going to start just by creating this on the local documents, and it can be here. Just pre-save it, and now that we've saved it, we can open it in Visual Studio so that we can start writing code. Now, a solution was created for Service Studio, and for Visual Studio, and Visual Studio is now opening it, and we're going to see the code that is generated. Here we go. Now this C# file is the one I'm interested in, so I'm going to double click on it. It has the name of my extension, so this is the one that has the code that I want to write. And here we go. Now I can see how Service Studio converts this to C#. I have the price out output argument converted to a decimal, which is the corresponding C# type to the currency type in the platform. I then have price in and minimum currency as arguments. And I simply assign the value that I want to price out. Now I have on my cheat sheet the exact formula that I want to use, which is this one here. I'm going to copy this and to paste it over here. And this is the result of my extension. I simply save this file and I'm all set. And this is pretty much what I need to do to create an extension with custom C# code. I'm going to close this, and now I'm going to do the same thing but for Java. So this is going to launch my Eclipse editor, IDE, to allow me to edit the Java code that corresponds to this function and has the same functionality. So basically the process is the same, except the UI of Eclipse is different from the UI of Visual Studio, and the actual code in Java is slightly different than in C#. But the functionality is there. So let's stretch Visual Eclipse. Still loading the packages. Let's wait 1 second. Here we go. And now in Actions, we have this Java file, which is the one we are interested in. Now this dummy Java, it's always here. It's required so that Eclipse doesn't complain about an empty something that doesn't have any Java files. Just leave it there. Don't worry about it. It doesn't do any harm. It's just there to make sure everything works and no software gets confused about it, about the way the structure is created. So pretty much the same thing. I have here my function with an input argument. In this case, the type in Java is called big decimal, and another input argument, which is the minimum currency, and this will return me a result. The result being a new object, which is created here by Service Studio, and that will be an object that has an output parameter, which will be a big decimal again. So I'm going again to copy my code from the cheat sheet that corresponds to what I've just written in C#. Let's see. I'm going to paste it here. It's the exact same thing. So just delete that original line and save the file. And that's it. Okay. I press Ctrl S to save the file. Sorry you didn't see that. Now I'm going to close this, and basically I've written the same idea, the same functionality, both in C# and in Java. And now my extension will work on both servers. It's still here. It states that it's destined to both servers. Of course, when you deploy to a .NET server, only the C# version is compiled and delivered. When you deploy to a Java server, then only the Java version is delivered. On my test server, this is the .NET server, so only the C# version will be uploaded. Hopefully, the code will have the same semantics, so it will work identically for both. I'm going to start the processes. I could go forward and use this one, but I'm going to use one at a time. Just start by verifying my extension. And automatically, once this is done, Service Studio suggests the next step, which is to save. So I'm going to just follow this wizard, just save it. And it's saved. Now I'm going to upload it. Uploading to the server. And now finally publish it. And that's it. Publish is done and everything is ready. So I close it just in case. I hit save. This is an old habit of mine. Just save twice, save every time. So going back to Service Studio, to the prices module, I'm going to add a dependency, which is the extension I just created. Let's go over to MC prices lib, which is exactly this one here. You see the ZIF icon there, so it's an extension. I'm going to use a round price action. Here we go, price out, price in, and minimum currency. Okay. And now, suddenly, in my logic, in dependencies, I have an extra thing here, which is the MC prices lib module with the round price action, which I now can use anywhere. Because this is a function, yes, I programmed that in the extension itself. I can use it in expressions. So I'm going to use it in every single expression. So here we go. I'm going to round this value here to 0.05. So let's start by rounding round, autocomplete, and autocomplete even works with these kind of things. So round price, this, comma 0.05. And it's the same thing everywhere. So we're just going to copy this so that it's easier. With the opening bracket, it's even easier. Copy it, hit OK, and then keep on working with the other three. Run by 0.05. done, and comma 0.05. That's it. And now, hopefully, our output will have all values rounded not to cents, but to multiples of 5 cents, rounded up. Let's see if this works. Okay, let's open. And here we go. 125, 140, 1.05, and this is true for every single value that is here. We now have rounded up all values to a multiple of 5 cents using C# code and Java code from an extension.
So this was the first demo of creating an integrations extension module. It's actually quite simple to do this. You see these demos even on the developer bootcamp. But what's a bit harder when you think about it is how to debug these extensions. Now, how can you debug an extension when you can't set breakpoints, platform breakpoints, inside the C# code? And you're actually running that code on the server. You have your Visual Studio on your development machine. It's really not trivial. But we have at least two different solutions that work for debugging and testing, and that's creating a console project and audit logs. We're going to watch a demo to see that happening.
In this demo, we're going to test our integration, our C# and Java code that performs the rounding to the minimum currency that we have defined to see if it works. And I'm going to do that in C# itself, in the native editors, Visual Studio, and Eclipse for each language. So we're going to open Integration Studio. We have here our extension. Let's start with C# and Visual Studio, and we're opening our project. What we're going to do is create a new project in the same solution that was created by Service Studio, a new console project that's going to call our function. So we're going to add a new project. This is going to be a console application. We're going to call it console test. Here we go. And this console application will require a reference to our MC prices lib project so that we can use the function that we have defined. And this is the console application we have here, and I'm going to use my cheat sheet just to write the code for this console application using declaration, and main will have this code. Basically what we're doing is calling our round price function. That price will give us the output in this local variable, which is initialized to 0, and it passes the arguments 2.22 and the minimum currency of 0.05. Now, if everything works properly, when we run this application, of course not. We have to set this as a startup project, obviously. This was the lib that was initially set as startup project. That's not what we want right now. We want to test the console. So let's try this again. When we launch this application, what happens is the output of the result 2.25. Let's see if that is the case. And that is correct. So we can use this technique to call our function with multiple values, have a for next loop here to test multiple values, use unit cases, unit test cases, use actual platform debugging to see what's going on, why the values aren't correct. And this can be done on the Java side as well. So let's see how that works. We're going to open up Java and open up the Eclipse editor. The idea is very similar. While we wait for that to load, we're going to just start copying from the cheat sheet those lines. And here we go, Eclipse is running. And as usual, we have our function here with the rounding code and so forth. So what we're going to do is to add a new Java project. Let's call it console test again. On this console test, we're going to add a new Java class. We're going to call it console round test if you want, and make sure it has a public static void main so that it becomes a console application. And this creates our basic structure. Now again, we need to reference our main project. We're going to do this, Java build path, projects, add our main project, which is called J2EE. This was created by Service Studio. And now we just paste these lines into the body of our editor. And that should be it. So let's start up the console application. The output should come over here, and here we go. 2.5. As a result of this rounding, actually, I seem to have a bug here. So this could be it. Let me try and check. Let's try this again. 2.22. 2.25, that's it. Okay, here we go. Okay, so I had a bug in my rounding function, and because I can now see the actual function running locally with a test value, I can immediately start testing out values and changing my code to figure out what's wrong until it finally shows up with the correct values. So this kind of test is very simple. It's very quick, gives you full access to the platform, to the IDEs, debug functionalities. You can run, unit testing and so forth. But it has a major drawback. Because you're running a console application in each case, you don't have access to the actual OutSystems libraries. So anything that uses stuff from the platform won't work. It will just crash with an error. So what can we do in those cases? Well, we can add actual logging or auditing. So this is the function that should be used in C#. I'm going to copy this. Actually, I'm already with Eclipse open, so I'm going to use the one for Java to copy this here. This is available in online documentation, so feel free to read it. And I'm going to insert it not in my project, that's not what I'm interested in, but right here, in the middle of my function, a call to audit. And this will generate an audit call on the actual service center logging facility. So this is the name of the module that's being used. This is simply for logging purposes, and this is the string that's being logged. Basically, I'm showing what is the price as input, then in parentheses what we're rounding it to, and then equals to, and the result of the rounding. Okay, so I'm going to save this. I'm going to leave Eclipse. I'm going to close this. I'm going to go into C# and do the same thing. While it opens, I'm going to copy the same line for C#. Here we go. And here in my function, my round function, I'll just add the auditing or logging code, whatever you may want to call it. Save. And the idea is the same. These parameters are reversed in Java and C#. So this is the string that's going to be shown and the module name. I'm going to copy this. I'm going to need it later. So that's it. Let's see this working. And that will be working live with running the actual application. So I'm going to publish this module, update dependencies as usual in order to test and see if this shows up in Service Center. So right now I'm publishing my extension. That's it. It's published. And back in Service Center, I'm going to refresh dependencies. Okay. Again, the interface of the module hasn't been changed, so I don't need to go over to the model, press refresh, and select more or less items that have been made available. I just need to open the dependencies user interface and say OK, and automatically they're refreshed and all the links are redone for me. Now I'm publishing it, and let's test it. And here we go. It's still working as usual. Nothing has changed in the screen as expected, even though we created console application projects on each of these solutions. They did not affect our extension. Now let's go over here to Service Center, and let's search in the general log for a module that has the name prices round. I'm going to filter this for prices round, and here we go. We have multiple loggings of these calls, and here we go. For instance, the first price was 1.36, 1487, so forth. We are asking it to round to 0.05 multiples, and the result was 1.40, which is correct, and so on. So by using logging, I can look at the logs later on and double check if everything seems okay as far as my extension goes. And that's it. Be sure, however, as an important note, not to leave your console applications part of the extension. Now, I usually do this here. For instance, we have one here, and we can ask for it to be included in the extension. If it's included, the code will go along with the extension, will be recorded in the ZIF. Again, it doesn't have any impact on your module, but it may have security ramifications. The way you're calling your actions, your internal functions, may divulge information that is handy for hackers. So let's not do that. It might be a bad idea. If you really want to debug using a project, a side project, do it occasionally, then delete it, or do it in a separate project, a separate solution, so that it really doesn't go along. It isn't served along and published along with the ZIF.
That was integrations in terms of extensions. How to debug your extension when you're creating code by either creating a console application or by logging.
Now we're going to try and connect our prices core module with an external database, so that the information that we have here on our internal entity called product being returned by the get products with prices action in this aggregate actually doesn't come from this internal entity, but from an external database. In order to do that, we're going to use an extension to expose in the OutSystems world the entities that are available on an external database. Now, the first step to do that is to go over to Service Center in the Administration tab and Database Connections and set up a new database connection. I already have one here, the Northwind database from our bootcamps. It's a demo database. I have defined its name, the type of server that's being used, the address of the server, access, user and password, and so on. We can test the connection to see if it's successful and then save it to use it in this environment. Now we have the connection established to an external database. How can we then make it available to the OutSystems world via an extension? We have here our extension in Integration Studio, and all we have to do to import it is to go over to Entities and use the wizard Connect to an external table or view. Now, we simply follow the steps. This is extremely simple. We simply select which is the connection configured in Service Center that we're going to use. Then inside that connection, which are the available databases? We're using the Northwind 1 database. Now, even though we're using something that we already configured in Service Center, this wizard simply uses part of that information to make the work easier for us. But it allows us to configure further databases that are inside that connection. So I'm still want to use the Northwind 1 database. Now it shows me the available tables and views which are in that external database, and then the ones that I'm going to use, the ones that will be converted as entities. Note, however, that this conversion is live. No data is actually moved to the extension. This is simply matching and mapping the actual layout of the tables, attributes, and so forth in the OutSystems world. Now I'm going to select the products table. I could select a certain level of related tables to be added along with that one, but I'm not interested. I just want the products table, and I'll move over to next. And now, what is the logical database name? Now, this is the name that the extension will use internally, and then I can reuse that name and attach it to a physical connection for each different environment. We'll see this in a short while. Now I'm going to call it just the Northwind demo database. And voila, the wizard has generated an entity called products, finish, and we have it here, the products. Now we can see the attributes here. We can also select them here to add more information to them. For each attribute, I can select what is the data type that it carries. Now, I can adjust this in the database, for instance, that there's this price here that this automatic wizard established as being a decimal. Actually, this is a price, so I want it to be a currency. So I can adjust this to my liking. These are actually platform types that I can assign to each attribute, to each row, to each column in this table. Now, having accepted this is okay and this is fine. I'm just going to save and publish the extension. Now, there will be one extra step here after this publish, which is configure. Because like I said, each environment will assign the logical database name to an actual configured connection in this environment. And we still need to do this. This is so that a development environment connects to a development database, a quality assurance environment connects to a quality assurance database, and a production environment connects to a production database. And we can simply reconfigure this here, never having to change the actual module. the module still uses the logical database name, and we can simply push the same module without recompiling from an environment to the next as each iteration in development approaches production. So I just hit apply, and as soon as this is it, okay, it's now saved. So I go over back to my prices core module, and I'm going to add a dependency here. And the dependency is the prices lib. And I'm going to add the products table. Here we go. The products entity, which has all these things that we've seen. And now in my data tab, besides the local product entity, I have a product entity from my extension called products as well. Now if I publish this, I can actually try and preview the data that's there using the aggregate editor. So one important thing to note is that from this point on, this entity is just as much a first-class citizen in the platform as this one here. This one is in the OutSystems database, and this one here is in an external database that the OutSystems platform can connect to. No data has been imported. We've only defined in the extension how to convert each column to the proper data type in the platform. And that's what's happening here. So if I simply drag it here, it works like any aggregate. If I double click on it, I can open it, and it's trying to preview live data, and this is the live data that's there. So I can use it just like my local database. So my local database had an ID and a name. I still have here an ID and a name. It also had a unit, which is simply text that describes kilogram or something like that. I can use this one here, quantity per product, for the same purpose, and then a price. And I can use this column for that same purpose as well. For demo purposes, this was probably in dollars, but we can assume for demo purposes again that this is in euros, and use this column here for the same purpose. So by using only some columns, I can simply now start replacing in my module this aggregate here for this one here. Now, the process is simple. It's, however, fairly lengthy, so I'm not going to go into that. But this is the basis of trying to access external data from the platform.
And that's it. That's how we can access external databases from the platform using extensions. That's the end of our webinar. I hope you've enjoyed it.